Hi and welcome. Today I'll be going over the explanation of the solution to min stack. So we need to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So there are many ways to do this problem, but the key is we need to make sure that all these methods are done in constant time. So we need to be a little clever with this problem, and what we're going to do is we're going to initialize two arrays, one called stack, which will just be our stack, and then one called min, which will give us the minimum element at each point in the stack. When we are we push into the stack, we're going to make sure that min keeps track of that. So the reason we're going to use arrays in this is because an array can act like a last in first out data structure, and a stack is a last in first out data structure. So if we're just using push and pop in our array, it's going to act like a stack, and so it'll be a last in first out data structure. Sorry, I repeat myself a lot. So I'm going to go through an example. I would say the trickiest method here would be push, but the rest are pretty straightforward. I'm going to push. Let's say I push in 5. So there's nothing in my minimum currently. So I know that 5 is the minimum. And then of course I have to push 5 into the stack. Then let's say I push in 10. So I push in 10, I check, is 10 the minimum between 5 and 10? So is 10 less than 5? No, it's not. So I need to push in 5 instead. In min. So I push in the top element, basically the last element that was pushed into min, I'm going to push that in again. So the top element. And then of course I have to push 10 into the stack. Let's push in 2. So we push in 2, we check, is 2 less than 5? Yes it is, so I'm going to push 2. And then of course I have to push 2 in the stack. Let's do another one, let's push in 11. So is 11 less than 2? It's not. So instead I need to push in min, I need to push in the top element, which would be 2. So I push in 2, and then of course I have to push in 11 into the stack. Yeah, so the most important thing is min and keeping track, okay, between these two, what I pushed in and the latest element in min, which one is the minimum between the two, and then push that in. Pop is very easy. So if we do pop, we're just gonna pop off this and pop off this. And then if I do getMin, I'm gonna return the top element in min, which would be 2. So the minimum of this stack is 2, and it's because right here it's the top element in 2. Let's do pop again. Pop is really easy, just pop off both of them. And then if I do getMin, it's gonna retrieve the top element in min. So the top element in min would be 5, and you get the idea. I'm gonna quickly code this out. So we're gonna do this dot stack equals an empty array, then this dot min equals an empty array. So push. So if this stack dot length is 0, so I'm just gonna take care of the min array first, and then at the end I'm gonna push into stack. So I'm gonna take care of the min array. So if my stack is empty, my minimum of course is the element that I'm pushing in. This dot min. Else there are things in my stack. So now I need to check what is the minimum. So the minimum will be math.min between x, the element we're going to push in, and the top of the min array. So that would be this dot min dot length minus 1. Then this dot min. Oh, minimum. Okay, and then of course then we're gonna do this dot stack dot push the element. Okay, so push is done. Pop is gonna be really straightforward. We're just gonna do this dot stack dot pop, and then this dot min dot pop, top is the top element in the stack array, and the top element is the latest element pushed in, so we're just going to retrieve the last element in that array. So return this dot stack dot, this dot stack dot, this dot stack length -1. And then getMin would be the top of the min array. So it would be this dot min. So real quick, let's just go over all the time complexity. So push here, it would be constant time because all we're doing is pushing, and when you push at the end of an array, it can be done it's done in constant time because we're not re-indexing the array. Like when you do shift and unshift, that re-indexes the entire array. So it actually has to go through the entire array, and that's done in linear time. But with push, it's done in constant time. So pop, same thing, pop is done in constant time. Top, retrieving the specific element in the array, that's done in constant time. And getMin is also done in constant time. So we satisfied the condition that this needs to be done in constant time. So I'm going to run the code. I'm going to submit. Okay, so I hope this helped. I'm so sorry if my explanation was not that great. I'm practicing on how to explain things, I guess. I hope this helped, and thank you so much for watching.